Hi everyone, I'm Yihan, along with my teammate Zhan from DCS 205. We would like to present our AACS 2034 Fundamentals of Computer Network assignment. In this video, we present our network design proposal for TAXS Solutions and Berhad. So this is our table of content. We will start with the introduction. As their network engineer, we have designed a local area network to support various departments across multiple locations. These include administration, sales, customer service, digital IT division, and R&D labs. Using Cisco Packet Tracer, we have tailored LAN set up for each building, all under the IP address 10.0.0.0/8. So as this diagram shown, location A house administrative department on the second floor, sales department on the first floor, and customer service department on the ground floor. The digital IT division, which consists of gaming tech, big data hub, and cybersecurity unit, are in different floors of location B, which is next to location A with a distance of 500 meters. Besides that, there are 5 research and development labs in location C, which is 200 meters away from location A. So next, we'll go to addressing design. As question mentioned that we need to consider number of addresses needed for 20% growth in all areas. So we need to calculate the number of hosts required after 20% growth in each department. So for administrative department, the number of hosts is 496. So we times 496 by 120%, we get 595.2. Then we round up to 596. So 596 will be the number of hosts required of administrative department. Then other department will calculate the same thing. That's how we get this host growth table. According to the host growth table, we can calculate the actual number of switches needed in each department. So for administrative department, the number of hosts is 596. So we can divide 596 by 24. We get 24.83 round up to 25. Then 25 will be the actual number of switches needed in administrative department. I need to mention that we decided to put our router at location A, which means that the switches in location A connect to router, we are using copper cable. Then others location, which is location B and location C, we are using fiber optic cable. Because of the number of switches needed and the number of hosts is very huge, so the network topology is provided just an example. So this is our network topology. The blue color one is location A, the green color one is location B, then the yellow color one is location C. Each department has one switch connect with three PC. So as I mentioned, our router is at location A. So the connection between them is copper cable, which is black color one. Then the connection between the switches in location B and location C, we're using fiber optic cable since their distance is more than 100 meters. Okay, next I will explain how to calculate the subnetting table. According to the host growth table, we can know the largest number of hosts required is 596. So we need to calculate how many bits that we need to cover 596 hosts. So we can use 2 power of 10, which is 1024. It is enough to cover 596 hosts. For your information, we are doing class A and it's a custom subnet. So our default subnet mask will be 255.255.255.0. So because of we need 10 bits, so the network portion should borrow 2 bits to the host portion so that the host portion will become 10 bits. Therefore, our subnet mask will become 255.255.252. The prefix length is written in CIDR notation. So in this case, 2 bits are borrowed, so the prefix length is 32 minus by 10, which is 22. That's how we get our host given, subnet mask, and the prefix. So we are doing class 2 network, so the host given and the subnet mask and the prefix will be same. So to the last point, since 2 power of 10 is 1024, then 24 divided by 256 is 4. So we can add 4 to get new network address. We all know that the first address and the last address is network address and broadcast address. So the network address of administrative will be 10.0.0.0. Then the first usable host is add 1 to it, which is 10.0.0.1. Then we can add 4 to get next network address, which is 10.0.4.0. Then we minus 1, we get the broadcast address of the administrative. So it will become 10.0.3.255. Then we minus 1 again to get the last usable host, which is 10.0.3.254. Then others department will continue the same step to get all the value. This is how we get this subnetting table. So that's all for my part, and I will pass it to my teammate Zhan.
Hey guys, my name is Zhan from DCA Group 5, and now I have to start with the addressing table part. Okay, let's start with the router table first. The router is a networking device that forwards data packets between the computer networks. So I'm using it to connect multiple switches together, which is the device column here. For the interface of the router, I'm using the gigabit internet to connect between the switch and router. The O of the SUNET mask of the intermediary device will be the same and have explained by my teammate before, which is the 255.255.252.0. For the router IP address of the different departments, I assign their respective last usable IP address, which is starts with the 10.0.3.254, 10.0.7.254, and so on. Okay, for the other addressing table, which is the seven different department in location A, B, and C, almost in the same pattern like the switch interface is using the VLAN one and the PC is using the network interface card. The SUNET is the same, and for the IP address of the switch, I'm using the last second usable IP address for this network, which is the 10.0.3.253, and the IP address of the end device. Design the 3PC as example and start the sequence with the first usable IP address, which is the 10.0.0.1 to 10.0.3. For the default gateway of the switch and end device, actually is using the router IP address. Okay. For the location B and the location C department addressing design, almost the same as location A. No need to explain more. Now I have a demonstration for you on how to configure the intermediate device and assign the IP address and the other operations. Okay, this is our actual topology. And now I random select a switch to configure the hostname and the password. In the CI command, go to the enable and go to the configure terminal to set the hostname and go to the line console 0 to set the password. Remember to type the login and exit to the configure terminal to enable the password and enable the secret. You can encrypt your password by type the service password encryption and go back to the enable to check the configuration, hostname, secret, and password. Okay, after that, you can go to the configure terminal and type the interface VLAN 1 to set the IP address for this switch is 10.0.0. No, 10.0.3.253, and the SUNET mask is 255.255.252.0. And remember, exit to the enable, tap the copy running setup to save the configuration. Okay, now configure the router. For the hostname and password is same with the switch, and for the IP address, you can refer to this. It's using the gigabit 90, and in the configure gigabit 90, assign the IP address and the subnet mask, refer to the table, and for all the PC in the desktop IP configuration, assign the IP address, subnet mask, and the default gateway, refer to the table. After that, you can try to ping from location 1, location A to the other location. I'm using the PC0 as example and go to the command prompt, ping to the now I try to ping to the location B 10.0.12.2 10.0.12.2. When you initially ping from one PC to another PC, there will be a delay or timeout for the first few packets due to the ARP process. It doesn't matter. If the destination of the PC replies, it means that the ping connectivity is success. That's all for my presentation. Thank you.